Welcome. In this video, we are going to look how you can troubleshoot any electronics device that has problems or faults. When you talk about troubleshooting, it means all steps or procedures used in finding faults of device and how to fix or getting the solution of that faults. We are going to see all steps and the procedures used in troubleshooting of electronics devices like in subwoofer, computers, televisions, and other electronics device. We're going to troubleshoot this subwoofer so as you can be able to troubleshoot other subwoofers. In troubleshooting, normally we start with easiest and fastest steps and we are going to end up with longest and hard steps. We have 12 steps that you can use in troubleshooting. We're going to study all steps. We can group all troubleshooting steps into two groups. First group contain 3 steps which done before opening or to unscrewing your electronics device. It means can be carried out of your device. And the second group or those procedures or steps that done after open your device or done inside of a device. We're going to start with procedures that you can done before opening the device. First steps is to get user information or user details. It means you are going to ask user of the device about the problems of the device and how the device get those faults. When you have user details will help you to know the locations of the problems and you will go directly to correct it at a very short of time. Also, it reduces the number of procedures of troubleshooting. So the respond of user will be according to the problems of that device. Example, my subwoofer has no bass sound, my television not show any signals or pictures. It depend on the kind of device. In case of this subwoofer here, it has no bass sound and tweeter sound, or I can say no sound that come out from this subwoofer. So this information give me prediction that the faults will be on speaker, amplifier, and so on. In case of this subwoofer here, it has no bass sound and tweeter sound, or I can say no sound that come out from this subwoofer. So this information give me prediction that the faults will be on speaker, amplifier, and so on. Step number 2 is to confirm the presence of problems on your device. You must make sure that you confirm that device has problems, because user information sometimes cannot be enough to give you a clear picture or directions where to focus on your troubleshooting. So this will help you to go direct and to predict more where the problem is, so you must confirm by turn on your device and see how it works and how the problem is. We are going to turn on this subwoofer and to see how it work. We see no any sound come out after turning on this device. This is how you can confirm the presence of the problems of your device. Now we're going to carry out step number 3, which is to make inspection on the main cable or plug cord. I mean the cable that take power from socket or extension to the device like this cable here. This step is very important especially for electronics device which doesn't turn on. I mean no any signal come out after turn on. So it is very important to carry out visual inspection on plug cord for any physical coating like rust. Check physical and isolation damage of the cable. And some kind of cable like this has fuse, so check continuity of the fuse in all terminals, I mean phase neutral and earth terminal. So as to prove cable is working by using multimeter. If you suspect any damage, fix it, and try to power it to see if problem have be solved. Step number 3 is last step of troubleshooting before opening device. We are going to see steps which can be done after open or steps which done inside of the device that will help us to identify fault present in our subwoofer. After getting inside the device, first thing to do is to clear or to remove dust and the spider web, and all unwanted things, to make components in your PCB to look clean. Will help you to read components values, but in cases of this subwoofer is clean. Another thing is to determine all parts and wires present in devices and to know where they are coming from and where they are going. Like in case of this subwoofer here. We have this cable for input home power supply which pass at this switch here and get into the PCB at this connector. This one is another kind of power supply which is DC 12 volts from solar power or other sources and pass through this bridge rectifier then to get into PCB. This wire is for antenna as you see antenna diagram. These all wires come from display to the PCB to connect PCB and display. These wires connect base speaker. And this is our main PCB that connect all loads, I mean display and speakers. Let's continue with step number 4, which is to check input powers that needed by the load so as the load can be able to function. In case of this subwoofer we have two loads, which are display and speaker. So we are required to check for required power by each load to make it to work. In this subwoofer here no sound provided after turn on. This means that either no signal or power supplied toward the speakers or speakers have some faults. First let remove load connection. Is here it connect to the display. This here is for bass speaker. And for tweeter speakers are connected here. So we're going to check all powers required by the loads. When you check for power required by load you can use multimeter or load equivalent to the one you check. And is more efficiency when you use other new equivalent load to one you check, because sometimes multimeter can be difficult to use and it depend on device that you have. We are going to use multimeter to check all power needed by loads. But you have to know range of power required by each load, so as you can confirm for that amount. Like in this subwoofer display and speaker can work between 5 to 9 volts. Let's start to checking power required by a display. Good amount for making display to work. That is why display turn on. Let look on power required by a bass speaker here. The wire from bass speaker is connected here. The connector is very loose, must to fix it. No enough power here. This connector is connected here for backside. No power here that can make bass speaker to give sound, that is why no bass on this device. This white wire is ground which connected to this big trace. This positive terminal connected here. Let's prove by checking continuity. So a positive terminal of base is connected here. Let's check power between positive and negative terminal. This proved no power for base to function. Now let's check also the power required by tweeter speaker here. These two terminals are for output where tweeters are connected and these are input. Let's check power in output ports here. No power. Let's try to check at these connectors because tweeter is connected here, even here no power also. The end of this step, we have seen that no any power supplied by this PCB to the speakers to make speakers to sound. We can conclude that subwoofer has no sound because no power supplied toward the speakers. So we're going to check the cause of this in next steps. Step number 5 is to check functionality of loads. This step involves checking how the load respond if its required power will be supplied. We have two loads in subwoofer which are display and speakers. In a display system of this subwoofer no fault because it function good, display has no any problems. But in a speaker system no sound provided and this happened because no power supplied to speakers. The problem is not on speaker. I will not test them now. I will test them in case the power reached to them but still they will not function. The fault is on PCB. So we going to carry out troubleshooting of PCB and see all indicators which can be used to identify and locate faults on PCB. Let learn all things to make you know where is fault in PCB. Let continue with step number 6, which is to make a visual inspection on your PCB. Visual inspection it means, by using eyes we will concentrate on looking all possible damage that can be seen by eyes on PCB. Firstly let us identify all components in this PCB. The home power supply input connector. R diodes form bridge rectifier. Capacitor which is JNC capacitor. Optocoupler. MOSFET. TL431A regulator. Step-down transformer. Diode for half rectification. 5 volts regulator. Capacitors. Input and output ports. These are heatsink used for cooling amplifiers so as amplifiers can work at required temperature. This amplifier for amplify bass signal. And this amplifier is for amplification of tweeter signals. Display connector. After identify components let continue with visual inspection. So we going to check present of damage like heat mark, burn mark, and smoke coating on PCB. Smoke coating and burn mark like this here. If this kind of damage present, check may be the source of fault. If is source fix it. Check if is source which make the device to failure in operation. This component is SMD resistor. Put multimeter in resistance mode and measure this SMD resistor. The resistance is good. Try to check also continuity of trace where this SMD is connected to other components. So the resistor has no any fault. Let continue with this step. Now look on any loss connection, any shaking components, and look for any missing components. Because sometimes component can fall down due to vibrations or short circuit that can melt the solder and make the component to fall down. Also make inspection of traces on PCB. Traces can damage due to burning effect, bruised, scratching or overlapping. Check also presence of short circuit, because sometimes components can get short like IC pins due to very close each other, and also SMD capacitor can get short. Another things to look is about bad soldering or incorrect soldering. Also check blown components like bulging capacitor and missing or breaking pins of IC. Through visual inspection of this step number 6, all components are good, no damage observed. Let us jump to step number 7, which involve making diode checking and continuity check. By using diode or continuity mode of multimeter. Use diode mode to test voltage drop in semiconductor devices like diode, transistors, LED diode, triac, diac, and bridge rectifier. Make continuity of some traces in wire that you suspect to have faults. Also make continuity in fuse and transformer present in PCB. Use continuity to check short circuit and a ground fault in PCB, especially in a very near components, traces and IC pins. Let's check voltage drop of this SMD diode. .561 voltage drop reading is provided by multimeter and forward bias. To test diode is bad or good, for good diode must have range of 0.2 to 0.7 voltage drops in forward bias, and it must read over limit in reverse bias. This diode is good. This also is good. And this one here is good. Let's check also the continuity of this base connector to the amplifier pins. This terminal is good. Let's check on other terminal. This is good also. This connector must be fixed due to shaking, but is not source of fault in this subwoofer. Check for short circuit here. No short circuit here. The end of this step number 7, no faults observed. Now let's move to the next step, which is step number 8. This step depend on your PCB. If your PCB contain components like LED diode, display, motor, even buzz or any component that can indicate flow of voltage. In this step, power must be supplied to the PCB. You must know the amount of power for a PCB to work. After power the PCB, check on the PCB to note if a LED diode comes on, and or the display comes on, so this will make you to know flow of current on PCB and to know where flow of a current reached. This event of a LED diode, and a display to come on, make no flow of a current, but it will depend on PCB if it has components to show the flow of voltage. In this PCB here it has no LED diode or display, so nothing to note about flow of a current on this PCB in this step number 8. Let us proceed with step number 9. This step required to supply power and to check the power supply block, but a lot of electronics devices use linear power supply system. This system has few components, which a transformer, bridge rectifier, diode, capacitors and regulators. Power the PCB, then measure voltage flow across transformer, regulator, rectifier, diode and capacitors, if is one of required amount. In this PCB, we can see power which is 230 voltage get into PCB through this 2 pins. Then pass across this bridge rectifier. Other AC voltage pass across this step-down transformer. Then in this diode, then in capacitor, and then in this regulator. Let's check if power supply block provide voltage to loads. Let's check if this power supply block provide voltage required by load which is display. Because this is 5 voltage regulator that provide 5 volts to the display, which flow in this way toward display connector. Let's check DC voltage, so multimeter must be in that mode. This here is input, and this is output, and the middle is ground terminal of our regulator. Let's check if output terminal provides 5 volts toward this display connector for display to work. Firstly, check the output voltage of regulator is good amount. Check also the input of regulator which is 10 volts from step-down transformer. The input power is good. Supply block has no any fault. We have also power flow around this middle area. Let's try to check. Check it through this regulator, but it has no any fault. Let's move to the step number 10, which is to check the power supply block in individual components. This step involves checking of each component present in PCB, so as to confirm that all components is well functioned, and also to trace flow of voltage in all components and compare it with required value. If incorrect value is observed in check a certain component, remove that component from PCB for more test or individual testing. We have already checked on power supply block which comprise transformer, regulator, rectifier, and capacitor, and voltage flow is good in this block. Even at this middle part, we have already checked on some components like this regulator is good. And all capacitors are good, no budging. Now let's focus on IC checking, because no fault detected in other components. Now we're going in step 11, which is IC check, so we are going to carry out IC check. But if you're not familiar with particular IC found in your PCB, take IC data sheet to know input, output and all specifications. In this PCB we going to focus with 2 IC amplifier. Amplifier for bass and another is for tweeter speakers. On this PCB we have 2 amplifier which are T2025. Let's see how base connector is connected from amplifier. Negative terminal of base, which is this white wire, is connected to this ground of IC. And positive terminal of base is connected from these 2 pins connected together by capacitor. As you see in picture, so base is connected from this left amplifier. Let's check connection of tweeters from amplifier. This is positive connector of right side tweeter. Its trace come from this direction. It has connected here, in these 2 pins. And this is positive connector of left side tweeter. Its trace come from this direction. It has connected here, in these 2 pins. Boost and out pins. And tweeters are connected in the right amplifier. This is pin diagram of all 2 amplifiers. In this one here is input pin, and this is out 1, and this is boost 1. So a speaker is connected to the amplifier is this manner. Positive terminal need 2 pins out 1, in boost 1, or can be out 2, in boost 2. Negative terminal connected to the ground pin. That is how bass and tweeter speakers are connected. So by using multimeter, let's check power provided by pins named out 1, boost 1, out 2 and boost 2 of these amplifiers if have enough power for our speaker to work. Negative terminal of multimeter on ground. No power from out 1. Boost 1, no power, and for out 2. And boost 2. No power also. Let's check also this amplifier. No power in all 4 pins, but input power reached to amplifier which is 10.61 volts through this Vs positive pin, so input voltage is getting into amplifier which is 10.61 volts. But no any power come out from amplifier so as the speakers can work, so we can conclude that both amplifiers have faults. But you can remove out of PCB for more checking by using IC testers to be more accurate. So no power to come out from amplifier that can make speaker to sound. Because the power that come out from this 2 pins of an amplifier, it pass across this capacitor for filter some noise and certain frequencies then to the speakers. Let's remove these amplifiers so as to replace with their equivalence amplifiers, and then to check again if power will come out from all pins required for the speaker to works. Hello friend, I am already replaced these damaged amplifier with their equivalence amplifiers. These here are amplifiers removed. As you see, let's use multimeter again to check power come out from amplifier pins. So as to verify that subwoofer can work now. These 2 wire connected to the bass, because bass connector was shaking, so I am connecting here at this time. So let's start with bass, negative multimeter terminal on ground. Check for out 1 has 5 volts. Then boost 1 has 10.46 volts. And input is 10.61 volts at Vs positive pin. Let's check again ground is here. A boost 1 has 10.49 volts at out 1 has 5.13 volts. And plus versus is 10.61. Reading will be the same to a boost 2 and out 2. Now let's check the tweeter's connection in right amplifier. A boost 1 has 10.49 volts. Out 1 has 5.20 volts. And plus versus has 10.61 volts. Will be the same for a boost 2 and out 2. So now our subwoofer can be used again because all sounds are good, I mean it has sound. Let us turn on it to see if it has sound now. FM tenure. Line in.
afraid. Yeah, I told him, don't hit the Bentley store. No credit card, yes, no more. I bought the crib and it's an escrow now. So you'll never have to worry about how you gon' pay rent no more. I brought my team.
This is how to troubleshoot subwoofer.